Hello guys, today we will solve the network problems of electronics and communication paper of GATE 2025. Okay, so this was the first question for 1 mark. Consider a part of electrical network shown below. Some node voltages and current flowing through the 3 ohm resistor is indicated, and we need to find the voltage at node X. Okay, so this current is given 1 ampere and this is 3 ohm, so V is equal to IR. So the voltage drop across this resistor will be V is equal to IR. So this is 3 volt. Okay, so this was 9 volt and there is a 3 volt drop across this resistor, so this voltage will be 6 volt. Now we know voltage is at both the ends of this resistors and we need to find the voltage at this middle point. So this we, from superposition, we know this standard result that this voltage will be 8 volt into 1 plus 6 volt into 2 divided by total resistance. So this will be like 20 by 3 volt. Or another way is like you know this voltage, so total voltage drop is 2 volt. Okay, and total resistance is 3 ohm, so the current flowing will be 2 by 3 ampere. Okay, so voltage drop across this resistor will be 2 by 3 into this V is equal to IR, so 2 by 3 into 2, so 4 by 3 volt. So 4 by 3 volt will drop across this, so here the voltage will be 8 minus 4 by 3 volt, so which is again 20 by 3 volt. So this was second method. Second question was from very basic question from parallel RLC circuit. Okay, AC part. So here this input voltage is given and this AC admittance are given. Okay, so we need to find this current. So we know that AC voltage is equal to AC current into that impedance. Okay, and so I will be equal to V by Z and 1 by Z is admittance, so current will be V into admittance. So IC will be equal to V voltage across the capacitor into admittance of capacitor. So voltage is, since parallel, so all will have same voltage, so this is like 1 upon 1 at an angle of 90 degree, 1 at an angle of 90 degree, 1 at an angle of 90 degree, and then this admittance is J 0.25, so J is plus 90 degree. Okay, J is plus 90 degree, so 90 90 180 degree, and this is 0.25. Similarly here this is 90 degree and this is minus J, so it is minus 90 degree, so they will add and it will be 0 degree, and this is 90 degree and this is 0 degree, so they will add, so this is 90 degree. Okay, so these are the three values. It's done. Third problem was on a two-port network. Okay, so the Z parameter matrix of a two-port network is like this, and Z, we need to find the Z parameter of this thing. So one way is like to use this delta into star, which is very easy because all three are same. So this will be like 2 by 3, 2 by 3 and 2 by 3. So this will be 2 plus 2 by 3, 8 by 3. This part will be 2 plus 2 by 3 is 8 by 3, and this will be 2 by 3. And now we just need to, once it is converted into T network, so we need to just apply 2 KVL. So KVL on this side will be 8 by 3 I1 plus 2 by 3 I1 plus I2, because I1 is coming from this side, I2 is coming from this side, so this will be 2 by 3 I1 plus I2 equal to 0. So which is 8 by 3 I1, 2 by 3 I1 plus 2 by 3 I2 is equal to 0. So this is basically 10 by 3 I1 plus 2 by 3 I2. So 10 by 3 I1, 2 by 3 I2, and since it is a purely resistive and symmetric network, so Z11 will be equal to Z22 and Z12 will be equal to Z21. But still, if you need to find, then you can apply KVL on output side also. So this is like 8 by 3 I2 plus 2 by 3 I1 plus I2, so 8 by 3 I2 plus 2 by 3 I1 plus 2 by 3 I2, so 2 by 3 I1 plus 10 by 3 I2 equal to 0. So Z21, Z22. Okay. Or another way is to, like, we can individually find both the parameters. So for example, if you need to find like Z11, then how can you proceed? So Z11 is basically V1 upon I1 when I2 is 0. So once I2 is 0, so voltage drop will be there will be no voltage drop across this resistor, so entire V2 will come across here. Okay, and now we need to find V1 upon I1. So it is basically like input resistance looking into this node. So basically it will be 2 and 2 are in series, so this is 4 and 4 in parallel 2, and then this part 2, so 2 plus 2 parallel 4, and this will be equal to 10 by 3 I1. And similarly it will be equal to Z22 also, and similarly Z12 is V1 upon I2 when I1 is equal to 0. Okay, so here what we can do is like when I1 is 0, so this current is 0, so voltage drop will be 0, so this voltage will come here only, so this current will be basically I is equal to V1 by 2, because voltage is V1 and resistance is 2, so I is equal to V1 by 2. Another equation we can make is like I2 is coming here, some part will go here, some part will go here, so the current that is going into this branch will be equal to total current I2 into using parallel resistor concept, so this resistor divided by total resistance, which is 6. Okay, because in this branch it is 2 and in this branch it is 4, so 2 plus 4 6, so this is basically I3 by 3. Now this and this current are same, so I2 by 3 is equal to V1 by 2, so V1 upon I2 is 2 by 3, so this is 2 by 3. So 2 is in this question. Okay, and the fourth question is like from AC part, so this I have not still studied the AC part. Okay, so thank you.